In problem number 3, we are going to find the area of the region bounded by the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. So let's sketch the graph of the function f of x first. So to sketch the graph of the function f, we need to determine the zeros of the given function. And for us to determine the zeros of the given function, we let f of x becomes 0 or equals to 0 and solve for the value of x. So in this case, let's solve for the value of x here. We have copy 3x cubed minus minus x squared minus 10x equals 0. So let's factor out uh, x 3x squared minus x minus 10 equals 0. And the second factor can still be factored into 3x x minus minus. This becomes 5 and this becomes 2. So since it's negative, so this is positive, right? Equals 0. That's why our values of x are 0, negative 5/3, and 2. So let's plot the points here. Let's plot the points of the function f of x. So we have 0 here, 2 here, and negative 5/3 somewhere here. Okay, so these are the points, but we need to determine whether which part of the quadrant of the rectangular coordinate plane does the graph pass through with a given interval. So we're going to use the sign chart, all right, for us to determine the behavior of the graph. So to do that, we have x 3x minus 2 or minus 5. Let's go back. Let's check. 3x plus 5x minus 2. So 3x plus 5 and x minus 2. So let's do the sign chart. Oops. Let's use the straight segments here, or the lines. Okay, here we go. And the zeros are, we need to arrange that in increasing manner. So we have negative 5/3, 0 and 2, and 0 here, 0 here, and 0 here. Okay, so on the left of 0, we have negative, 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 negative. And on the right of zeros are positive. Okay, and let's multiply all the signs here. So this becomes negative, positive, negative, and positive. So which means that from negative 5/3 to negative infinity, the graph, or the points of the graph f of x is below, and from negative 5/3 to 0, it's above the x-axis. 0 to 2, it's below x-axis, and 0 to positive infinity, that's above x-axis. So negative, positive, negative, positive. So let's go back to the let's go back to the graph, or to the coordinate plane. So we have negative, positive, negative, positive. That's the trend. Okay, so we have here, so this is 0, this is 2, 0, negative 5/3. So let's label. Okay, so this is negative. We have kind of here, going up, going down and going up. Okay, so this is the behavior of the graph. This is our f of x. Okay, so let's sketch. Let's sketch the second function g of x. That's negative x squared. So we have g of x, or let's use another color. Let's use blue one. G of x is equal to negative x squared plus 2x. This is a parabola, so this is negative x minus 2 equals 0. So x equals 0 and 2. So let's sketch the graph, 0 and 2. So we have here 0 and 2. And of course, the graph or the parabola opens downward since the coefficient of the numerical coefficient of the term x squared is negative. So we have this. Something like that. Oops. And the graph will intersect somewhere there. So, but let's determine, okay, let's identify. Oh, by the way, the function here is, this is our g of x. Okay, now let's determine the point of intersection of the two functions. Let's see if these are really the 2, 0, and the point here. All right, so we have, okay, so we have 3x cubed minus x minus 10x is equal to negative x squared plus 10 plus 2x. So let's simplify this. So 3x cubed plus x squared. Oh, so let's check our function f. Minus x squared minus 10x. Minus x squared. Okay, so this will be canceled. And let's, okay, so this becomes negative. This becomes negative. So this becomes negative 12x. Yeah, negative 12x, right? Go. And we can factor out. So 3x squared minus 4, minus 12 equals 0. So let's simplify. We have x times okay, so we have x squared minus 4 equals 0. So the factors are x times x plus 2, x minus 2. So therefore, the zeros are 0, negative 2, and positive 2. So, which means that the graph of the functions f of x and g of x intersect the x-axis at 0, negative 2, and 2. So therefore, let's solve for the y's. If it's 0, then 0. If it's negative 2, we can use the g of x, so as we can easily identify the value of y, okay, or the function value. If x is negative 2, negative, negative, so it's negative 8. If it's positive 2, that's 0. So the point of intersections of the two functions are 0, 0, negative 2, negative 8, and 2, 0. Okay, so let's identify that. Let's label this point of intersection. So here, here, and here. The point here is negative 2, negative 8, right? Okay. So in this case, All right, so let's now identify the regions bounded by these two curves. So we have two regions. Okay, let's identify these regions. We have this region, and the other one is this region. Okay, so let's say we call this area 1, and this is our area 2. Now in area 1, in our area 1, the green one is f of x. F of x is greater than or equal to g of x, correct? While in area 2, the blue one is g. G of x now becomes greater than or equal to f of x. So that's why we need to integrate these functions, okay? I mean this shaded area differently in a separate manner, okay? So now let's draw the rectangular strips. We have, okay, let me draw rectangular strips here. Okay, and also here. All right. Okay, so again, this is just the representation of all the infinite rectangular strips in a given areas. So let's label. So this is our x sub I, and this is our x sub I sub 2, let's say, or I sub j, x sub j. Okay, so we have, if this is our x sub I, this point now is our x sub I and g of x sub I. And this point here is our x sub I and f of x sub I, right? And if this is our point x sub j, this is our x sub j, and the green one is the f, so this is our f of x sub j, and this one is our x sub j, and the blue one is the g sub x sub j. Okay, so those are the points. And let's identify in area 1. In area 1, the length is equal to height, which is equal to what? The upper part is the f and the lower part is the g. So therefore, the height of the rectangular strip here is f of x sub I minus g sub x sub I, right? And our width here is delta x. So the width is equal to delta x, okay? I hope it's clear. And let's proceed to the next one. Okay, so here our height is the upper part, or g of x here is greater than f of x. So therefore, g of x sub j minus f of x sub j. Understood? And our width is delta x. Okay, so these are now our parameters that we're going to use. So we have area 1 and area 2. So let's solve. Now, since we have two areas formed here, two different areas, okay, since the position of the functions f and g change uh, from left to right, on the left side, from the left side, f was on the upper part and g is the lower part of the curve or of the region. while in the second area, G was on the upper part and F was on the lower part of the shaded region. So that's why we divided our integrals into, or the shaded regions uh, into two parts. Okay, so let's now solve for area 1, or oops, area sub 1. Okay, area sub 1 can be, that's length times width, which is, or the change of area sub 1. So we have the length was f of x sub I minus the length, the length is f of x sub I and g sub I times the change of, or the delta x. And using the Riemann sums, we have, this is I, okay, and a sub 1 is equal to the the limit, okay, as n approaches infinity, of course, the summation of f of x sub I minus g of x sub I times change of x, or delta x, from I1 to n. Okay, so let's now convert this to integral notation. Okay, so we have f of x minus g of x with respect to x. And our limits, lower and upper limits, are from -2 to 0, because this is 0, right? Correct? So we have -2 to 0. We're using the values of the x on the points since we are using vertical or rectangular strip, or our integral is with respect to x. Okay, or we're talking about change of x here. So that's -2 to 0. Okay, so let's substitute the functions. 0 to -2. Our f of x is 3x cubed minus x squared minus 10x. Correct? 3x cubed minus x squared minus 10x. Okay, that's our fx minus -x squared plus 2x dx. If I'm not mistaken, let's check. Okay, g of x is -x squared plus 2x, and our f of x is 3x cubed minus x squared minus 10. Let's see. Ah, yeah, right. We got it correctly. Okay, so let's simplify. So 0, -2. Let's simplify. So 3x cubed, and we can cancel the x square. Okay, then becomes, sorry, and becomes what? So -10x minus 12, so minus 2x. So that's -12x dx. Okay, so let's take the integral. So this becomes equals 3/4 x raised to 4 minus 6x squared. Okay, and to be evaluated from -2 to 0. Okay, so let's solve. Now, since our upper limit is 0, so therefore, all of the values in the first part is 0, minus, when we evaluate it by -2, this becomes, what's this, 16 fours to 12, minus, this becomes positive, oh, -24. -24. So therefore, the answer here is -4, positive 12. So area 1 is equal to 12 square units. So therefore, this is 12 units. Okay, now let's work on area 2. Okay, area 2. We are now on area 2. So area 2 is equal to length, or change of, okay, the delta of area J, we're talking about J here, length times width is equal to, okay, let's go back to the region. All right, so we have G of X sub J minus F of X sub J. Since G was on the upper part above the F of X. Okay, so we have G of X sub J minus F of X sub J times the delta X. So this is equal to area 1 is equal to the limit as n approaches infinity of the summation g of f of, sorry, g of x sub j, x sub j minus f of x sub j, right, multiplied by delta x as j starts from 1 to n. And of course, n is approaching infinity. So let's now, oh, this is area 2. Let's now integrate, okay? Express it using the integral, okay, integral sign. So we have g of x minus f of x delta x from, okay, let's see the limits of the integral. So we have 0, and here is, this is 2, 0, right? So from 0 to 2, okay. Or we can also check that here, or here, and here, okay? Okay, so from 0 to positive 2. And let's substitute the values of the function. So 2, 0, we have g of x is equal to, as I remember it right, it's x squared plus 2x minus f of x is equal to 3x cubed minus x squared minus 10x dx, if I'm not mistaken. Let's double check. Minus 10x, correct. Okay, so let's simplify. So 2, 0, and negative 3x cubed, and we can cancel out the x squares here. Yeah. And we have positive 10x, so positive 12x dx. Okay, and let's take the integral of the function. So we have what? Negative 3/4 x raised to 4, and the integral of 12x is plus 6x squared. And from it to be evaluated from 2, 0. Okay, so let's evaluate. So let's substitute first the upper limit. So this becomes 16 divided by 4, so negative 12, and 24 minus, since x is 0, so everything is 0, so this becomes positive 12. So area 2 is equal to 12. So therefore, since we're talking about the sum of the two areas, so area 1 plus area 2 is equal to 12 plus 12 is equal to 24 square units, since we're talking about area here. Okay, so therefore, our area of the region, okay, is 24 units. So 12 and 12, so we have 24. So therefore, the answer here is, answer is 24 square units. All right, I hope we got the same answer.